This is the second video looking at speed. The first video looked at the three formulae: S equals d over t, d equals st, and t equals d over s. This video will look at graphs, distance against time, where the slope of the graph will be the speed. So we'll be using mainly the first formula, S equals d over t. From the first video, this example was used. If you travel 360 kilometers in 2 hours 15 minutes, find the average speed. So you want to write the formula S equals d over t. Speed is distance divided by time. You need to divide the 360 kilometers by the 2 hours 15 minutes. But we want the speed in kilometers per hour, so we need to turn this 15 minutes into hours. It's 15/60ths of an hour. If you were to look at that as a decimal, it'd be 2.25, 15 minutes, quarter of an hour. 0.25 is a decimal. Or better still, on the calculator you can enter 2 and 15/60ths. So you can, on the calculator, have 360 divided by 2 and 15/60ths. The 15/60ths goes in using the fraction button. It will come out exactly 160 kilometers per hour. So that's the average speed, distance divided by time. If you get time in minutes, divide by 60 to make it as a fraction of an hour. Here we have a distance time graph, distance in kilometers, time in hours. The blue line is travelling at 30 kilometers in 1 hour. So distance divided by time is 30 divided by 1. So it's 30 kilometers an hour. The red line is travelling the 30 kilometers in 2 hours. Average speed, distance divided by time, 30 divided by 2, 15 kilometers an hour. So it's half the speed. It's not as steep. And the purple line is the 30 kilometers in 3 hours. So 30 divided by 3, 10 kilometers per hour. So the faster you travel, the steeper the slope of the line. So in a distance time graph, the slope of the line is the speed. The faster the speed, the steeper the line. And when you're on a journey, sometimes you travel fast, then you slow down, speed up, slow down again, speed up. So your speed varies on the journey. The average speed takes no account of speeds at any instant. It simply looks at the total distance you travel, in this case 30 kilometers, total time taken 3 hours. The average speed there will be 10 kilometers per hour. That black line is a theoretical speed of 10 kilometers per hour, but you're either travelling faster than that, that's where the line's steeper, or slower than that, that's where the line's less steep. Perhaps at this point, where the red line's parallel to the black, then the red line's 10 kilometers an hour at that point, but mostly it's above 10 kilometers per hour and below 10 kilometers per hour at any instant. Simply, the average speed is a theoretical speed. It's not a speed you actually do. So here, the total time taken is 5 hours to travel a total distance of 40 kilometers. But it's in 2 stages. In the first stage, 30 kilometers was travelled in 3 hours. So the average speed there is 30 divided by 3, 10 kilometers per hour. The next stage, the last 2 hours, to travel the remaining 10 kilometers. That's an average speed of 10 divided by 2, 5 kilometers per hour. So travelled at 10 kilometers per hour, travelled at 5 kilometers per hour. But the average speed for the whole journey is 40 kilometers in 5 hours, means an average speed for the whole journey of 8 kilometers an hour, 40 kilometers in 5 hours. So that blue dotted line is 8 kilometers per hour. It's a theoretical speed. They're actually doing 10 and then 5. But the 10 and the 5 were not involved in working out the average speed. They were irrelevant for the average speed. Average speed just takes into account total distance 40, total time 5 hours, and that works out the average speed. It's a distance time graph, and then the time axis, you've got to watch the units. So for example here, between 10 AM and 10:10, there are 10 little divisions. That means every division is 1 minute. And since that's 2 divisions short of 10:10, that time is 10:08. Whereas here in the second one, it's between 10 and 10:30. That's a 30-minute gap. There are 10 little divisions covering the 30 minutes. That means it's 3 minutes per division. And since that's 2 divisions short of 10:30, that is 6 minutes short of 10:30. That time being pointed at is 10:24. So that's 3 minutes and 3 minutes short of 10:30. The next one, there's an hour's gap, 60-minute gap, and there are 10 divisions. So each division must be 6 minutes. That's 2 divisions short of 11 AM. That is 12 minutes short of 11 AM. And that makes the time there 10:48, 11 minutes, 12 minutes short of 11 AM. And this one at the bottom, it's still between 10 and 11, but there are actually 12 divisions there. So that's 6 divisions up to this midpoint and another 6 divisions. So there's a 12 division gap. That means 5 minutes for every division. 60 minutes, 12 divisions, 5 minutes per division. That's there for 10 minutes short of 11 AM. So that's there for 10:50. So you've got to work out how many minutes each little division's worth. You've got to count them up and be very careful on the graphs because some of them are quite awkward. And this question here, on the time axis, there's 1, 2, 3, 4, 5, 6 divisions to this point, which is 9:30. And there's the next 6 up to the whole hour. So in fact there's 12 divisions there, so it's 5 minutes per division. So this is 9:05, 9:10, 9:15, 9:20, 9:25, 9:30 and so on. 5 minutes per division. So that's 12 divisions in an hour. Up the side, 5 boxes to get to 5, it's 1 kilometre per box. So you've got to look at the 2 axes, especially the time axis, figure out how many minutes per division, and on the vertical, how many kilometres per division. So the idea is the graphs of a journey here. It says cycling to the shops and back. So obviously went to the shops, stopped for a wee bit, carried on, and this is obviously shopping here, and then returned home. So this is the distance from home in kilometres. So how far is it to the shops? Well, the shops are this part here. That's where the shopping's done, 15 kilometres. How long do you stop to do a puncture? So there's a puncture, so this must be the puncture getting repaired on the way. So that's 2 divisions. Now it's 5 minutes per division, so that's 10 minutes in here. Stop to repair the puncture for 10 minutes. How long is he shopping? Well, this is the shopping here. If you count them up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divisions there. 5 minutes per division. That's 50 minutes shopping. 50 minutes shopping. What time did they set off for home? So this is what left for the journey home. So if you look right down there to the bottom, here is 3 divisions before 11 o'clock. That's 15 minutes before 11 o'clock, so it's 10:45. So set off for home at 10:45. How far is it to the shop? Well, that was the first question, 50 kilometres, so we're done. So that's the journey there. There's the same graph with the splits, and this time we'll look at the speeds. So he travelled at a certain speed. That's the first half an hour here. He travelled 10 kilometres. So half an hour to travel 10 kilometres means 20 kilometres in an hour. So that's 20 kilometres an hour for this part. Stopped for a while, then journeyed on. Now that's 5 kilometres going here. 5 kilometres, and there's 3 divisions. That's 15 minutes, quarter of an hour. So for that next part, the 5 kilometres took quarter of an hour. So that's 4 lots of 5, 20. 20 kilometres an hour again. It's the same speed. These 2 lines are parallel. Same slope, same speed. that was 5 kilometres in a quarter of an hour. Did the shopping and then returned home. Returning home, full 15 kilometres, and that is 15 minutes here for these three gaps, these three divisions, and then the full hour to 12 o'clock. So that's an hour and a quarter. So the 15 kilometres took an hour and a quarter for that last section. 15 minutes in 1.25 hours, that's 12 kilometres an hour. 15 divided by 1.25 will give you 12 kilometres an hour. So that's his speeds when he was travelling 20, still at 20, and returned at 12 kilometres an hour. However, for the whole journey, from start to finish, it was a 3-hour interval. 15 kilometres to the shop and 15 kilometres back. So the whole journey was 30 kilometres in 3 hours. So average 10 kilometres per hour. But wasn't moving for part of that time. So this average of 10 kilometres is including 0 kilometres when stationary here at the shops or repairing the puncture. The travelling speeds. So what about the average speed when cycling? So take away the times when he's not moving. That was 50 minutes here, and that's 10 minutes. So he was not moving for an hour, 50 minutes at the shop and 10 minutes for the puncture repair. So for 1 hour he wasn't moving, so he wasn't travelling for the full 3 hours. He was cycling for only 2 of these hours. So when cycling, the average speed 30 kilometres in 2 hours. His average speed actually cycling was 15 kilometres an hour. So the 10 kilometres an hour would be misleading because he wasn't travelling for 1 hour. So the cycling average speed is 15 kilometres an hour. So taking off the times when he wasn't moving, when he wasn't cycling. So there's a worksheet. If you click the link in the description, you can get the worksheet and it'll have the answers with it. They'll be on the sheet. There are questions just as you saw with this graph, working out average speed for the whole journey and when cycling, and also answering questions about distances and time and so on. So worksheets available if you click the link in the description. So there's a worksheet, 6 questions. This side here is all about the average speeds for the whole journey and just when travelling, and working out the speeds at each stage of travel, and it'll have the answers. It's also from the same link in the description, notes on speed. That was the time differences of the first video, the 3 formulae of the first video, and that's the graphs. Hope you find these videos useful. Thank you.